Hey guys, Professor McStud here to talk about equations in the y equals mx form. So here we go. We're talking about a linear relationship. Remember when we talk about a linear relationship, that's a constant rate of change is the same throughout. So it has to be linear to be able to write it in an equation. So that's what we're doing today. And then m is this little m right here. Stands for, not McStud, most of you may have thought that, it stands for slope. It is slope. So as we go through here, that's what that stands for. So slope, constant rate of change, those are interchangeable, and so we've already learned that going in, now writing the equation. So here we have the perimeter of a square, and it's proportional to the side length. So if the side length increases, so does the perimeter. So here we have the side length as your x and your y is your perimeter. So here's the equation, y equals 4x. So side length goes 0, it goes 0, 0. So it can tell that it's proportional. It goes through 0, 0. Y equals, also you can tell by the equation, y equals 4x. There's no plus or minus. It's proportional. Kind of until time that in, that's kind of irrelevant as far as in here. And then, so then as it increases by 4 every time, this is 4. So then you're finding the constant rate of change, which is 4. So the slope, or 4 divided by 1. So the slope of the line is 4. Also, rise over run is slope. So rise, I go up 2 over a half. So plus 2 over 0.5. I would not encourage you to do 0.5, but you can. You can do up 4, because this is 4. See how this scale is up to 4 over 1. So 4 divided by 1. Rise over run is slope as well. You get 4 divided by 1, which is 4. So all of this is to say, so here I'm going to take this equation. Here's y equals 4x. I can make a table, make a graph. Slope is 4. We're identifying that from that equation. All right, so here we have the amount of pizzeria charges then for the number of toppings, and then its proportional relationship. So it's shown right here, and we're going to find the unit rate or cost per topping. Basically, finding the slope. Slope, unit rate, cost per, this word per or every, each, all of that means slope. So I'm going to find the slope here. You can do this a couple of ways. You can go through here. It's kind of hard to see where these two go through. It looks like this is 250, and then this is 2 right there, and then 0, 0. So here's my x, y, it was at 0, 0, then it went over 2, up 250. So when I go through and I divide that, plus 250, plus 2, I'm going to get $2.50 divided by 2. So for two toppings, it's $2.50. How much is it for one topping? So for one topping, when you divide that, you get 1.25. So that is the slope, 1.25. That's the cost per topping. So for every topping extra, $1.25. So that is the slope, the constant rate of change, the unit rate, all of those interchangeable and through there. So here's another one. Our second example. We have 10 seconds after an elevator departed, it had descended 60 feet. After 25, it descended 150 feet. The number of feet descended and time are in a proportional or linear relationship. That means it goes through 0, 0. Linear means it has a constant rate of change. At what rate is the elevator descending? So I need to make a table here. So x, y. So after 10 seconds, it had gone down 60 feet, and after 25 seconds, it was at 150. So I can find this change here. That's plus 90. This is plus 15. So to find the slope, constant rate of change, all of that, I'm going to do the change in y divided by the change in x. So 90 divided by 15, which is going to be 6. So what does that mean? That means that it's every single second after 1 second, it's going down 6. Because I could really write this kind of sort of like this, 6 divided by 1. This was feet, and this was seconds. So if I'm trying to find it in 1 second, how many feet. That's where that comes from. So it's 6 feet in 1 second. That is the unit rate. Also the slope, also constant rate of change. So lots of different things going on here. Remember, we have slope has different hats. It can be the change in y divided by the change in x. It can be rise over run, which is also the same thing. Okay, it's rise over run. It is also the unit rate. It is also the constant rate of change. And it is also, major thing, is it is the m in y equals mx, going through and writing those equations. That is going to be your slope, unit rate, constant rate of change. All right, so that's what I have for you, slope, constant rate of change, y equals mx equations.